So now let's go a little bit more into data and measurement themselves. So statistics, what are statistics? The term statistic refers to numerical facts, averages, medians, percentages, maximums that help us understand a variety of situations. And statistics can also refer to the art and science of collecting, analyzing, presenting, and interpreting data. So data are facts and figures that are collected, analyzed, and summarized for presentation and interpretation. All data collected in a particular study is considered a data set for that particular study. So some vocabulary words. We have elements, which are the entities on which our data are collected. A variable is the characteristic of interest for those elements. The set of measurements for that particular element is called an observation. And a data set with lowercase n elements contains n number of observations. So lowercase n goes with when we're talking about a sample. Capital N will talk about the number of elements that you have in a total population. And then we also have the total number of values in a complete data set is the number of elements multiplied by the number of variables. So when we look at this in a data set, we see our element names. In this case, it's going to be our list of companies. Our variables that we're going to use for stock exchange, annual sales, and earnings per share. An observation would be the stock exchange value, the annual sales, and the earnings per share for Energy South. And then your data set is everything inside all of those observations for each of the elements for each of the companies. So we have 4 different scales of measurement. We have nominal, ordinal, interval, and ratio. And the scale that you use really kind of determines the amount of information that you have and also indicates the type of analysis that you can do that would be most appropriate. So we have categorical and quantitative data. So that means whether or not we can do a particular analysis depends on whether or not we have the right data. In general, we have more alternatives for the analysis when the data are quantitative, but we do have quite a few approaches that we can use with qualitative data as well. So when we're looking at our categorical or could be qualitative data, appropriate statistical analyses can be rather limited. We have to have labels or names to identify the attribute on each element. It can be, like I said a little bit earlier, it can be referred to as qualitative data. They can be either numeric or non-numeric variables, and they can be either on the nominal scale or the ordinal scale of measurement. When we're looking at quantitative data, we're talking about how much or how many. And so we consider they can either be discrete values that are measuring how many, or they can be continuous values that are measuring how much. Our quantitative data is always going to be numeric, and we can do any ordinary arithmetic operation and have meaningful results when we're using quantitative data. When we're thinking about the nominal scale of measurement, we have labels or names used to identify our attributes of that element. And we can either code it numerically or non-numerically. For example, if we're thinking about students at a university classified by the school in which they're enrolled, you could have a non-numeric label such as being in the business school, the College of Science and Health, or whatever. You can also use a numeric code to describe the school variable as well. But in this case, notice that 1 versus 2 numerically doesn't have any value, but it is indicating that that observation belongs to one group versus the other. If we're thinking about an ordinal scale, the order or the rank of the data is important or meaningful. So a non-numeric label or a numeric code can still be used here. So typically you see 1, 2, 3, 4, 5, but you could see first place, second place, third place, or freshman, sophomore, junior, senior in the case of university students where we're looking at classification. So when we're looking at the interval scale of measurement, you have all the same properties of ordinal data, and the interval between those observations is now expressed in terms of a fixed unit of measurement. And so you've now taken all these properties that we've looked at before and now said, oh, you know what, the distance between the person who finishes a race first and who finishes second is not always the same. But if I drive a mile away, a mile is going to be the same distance whether I drive a mile in Texas or if I drive that mile in Oklahoma. And so here would be an example. We have Melissa with a SAT score of 1985 and Kevin has an SAT score of 1888. And so Kevin scored 105 points less than Melissa did. And these are very set intervals, set amounts, and it gives us meaningful information. The ratio scale of measurement has all of the properties of the interval data that we've talked about. All of the properties of the ratio of two values is also meaningful. Ratio data is always numerical, but in this case, the zero value is included in our scale. So here, for example, the price of a book at a retail store being $200, while the same book being sold online for $100, shows us the ratio property that the retail store charges twice as much compared to our online price. Here's a nice graphic to kind of look at that overview of your scales of measurement. You have categorical versus quantitative data. Your categorical data can be numeric or non-numeric, and either nominal or ordinal data can be numeric or non-numeric depending on what you have. But quantitative data is always numeric and can be interval or ratio data. Cross-sectional data is when you're taking data at the same or approximately the same point in time. And so you might be looking at the number of building permits being issued in November in each of the counties of Ohio. Time series data is when you're collecting data over several time periods on the same person, for example. Here we have time series data, the average price per gallon of gasoline over a particular time period. Graphs of time periods help people figure out what happened before. They look at maybe some different trends over time and maybe do some projection for future time series data. Some data sources are internal company records, business databases, government agencies, industry associations, and the internet is full of data, all kinds. So if we look at some different data sources with the employee record, for example, they might have your name, your address, your social security number. If you look at credit records, they might look at your name, your credit limit, accounts receivable balance, and so forth. Some data sources that are available from government agencies include things from the Census Bureau, Federal Reserve Board, Bureau of Labor Statistics is a really good spot to get data, Department of Commerce, and so forth. Let's talk about data sources in terms of studies. So we have statistical studies that are observational, are considered non-experimental studies because you don't make any attempt to control or influence your variables of interest. So if I'm looking at the differences between smokers and non-smokers, I'm not going to force a non-smoker to become a smoker or a smoker to become a non-smoker just to suit my question for my research. So I'm going to take existing smokers and existing non-smokers and go from there. So that kind of makes it more of a non-experimental study. But if it's an experimental study, the variable of interest is identified first. And then we collect our variables or data on that so that we can control for certain things and how they influence that variable of interest. The largest experimental study ever conducted is believed to be the 1954 Public Health Service experiment for the polio vaccine. Nearly 2 million U.S. children's grades 1 through 3 were selected for that. Some other considerations would be data acquisition, so how much time it takes to get it, how much it costs to get it, as well as the errors from the people that were inputting and compiling the data for you.